Hey everyone, this is Bhargav Sudhar, and today we will learn how to construct a haze diagram, and that is very important topic. So in this session we will discuss, we will recall what is a poset and how to construct a haze diagram, and we will discuss some of the examples. So first let us recall what is a poset. So that is partial ordered set. Now let us recall the definition. So let capital A be any non-empty set, and let capital R be a partial order relation. We know that what is a partial order relation. So a relation is called a partial order relation if it is reflexive, antisymmetric and transitive. So a partial order relation on a set A. Now a set A together with this partial order relation is called a partial ordered set, or simply a poset. Now this ordered pair AR is called a poset. So this is, we know what is a poset, right? So this is just a recall. Now to represent a poset, we'll need a haze diagram. Fine. So poset can be represented by digraphs. So a simpler way of representing poset, that is called a haze diagram. Now let us discuss method to this find haze diagram. Now there are some few steps to find a haze diagram. So first, from digraph. So that means we need to construct a digraph. The first step is omit loops as the relation is reflexive on poset. Now we know that in poset the relations are reflexive. So the first step, we will remove all the self loops. Okay. Then the second step, all arrows that appear on the edges are omitted. So the second step is all the arrows we will remove. Okay, fine. Then the third step, eliminate, this is important. Now eliminate all the edges that are implied by transitive relation. Now what does that mean? For example, see, if A is related to B and B is related to C, then by transitivity A is related to C. Fine. So we will remove that transitive edge, that is AC. Okay, so we'll remove all the transitive edges here, for example, AC. Then fourth step, an arc pointing upward is drawn from A to B if this A is not equals to B and A is related to B. So we will draw an arc in upward direction. Fine. Each and every time we will draw whatever the arcs in the upward direction, such that just by looking at the graph we will be able to say that this point is related to this. Fine. Now let us discuss example. The question is, let capital R be the relation on the set A, and the set is given 5, 6, 8, 10, 28, 36 and 48. Now let R, the relation is given set of all AB such that A is a divisor of B. Then draw the haze diagram and compare it with digraph. Okay, so let us discuss solution. So here A is given and the relation is given, that is A is divisor of B. So in simpler manner, A divides B. Fine. So A divides B. So that is the divides relation. Now then the relation will be, so first we will write the relation. So this will be the relation. How? See, this is the divides relation. Now all these numbers divides itself. So 5 divides 5, 6 divides 6, 10 divides 10, 8 divides 8. So that means this 5, 5, 6, 6, 8, 8, 10, 10 up to 48, 48. These many pairs will be there. Then next, just fix 5. Now 5 divides 10. So 5, 10 pair will be there. Now then just go to 6. Now 6 divides 36 as well as 48. So 636 and 648 pair will be there. Then 8 divides which number? 8 divides itself also, and 8 divides 48. So 848 pair will be there. Now 10, then now 10, 28, 36 and 48. These numbers divides itself. Okay, so these many pairs, that is already we have discussed. Fine. So this will be a relation. Now this is the relation. First we will construct the digraph and then we will proceed for the haze diagram. Now see, just take all these points, that is 5, then 6, then 8, then 10, 28, 36 and 48. Fine. Now what is the relation? Now in the relation, each and every point divides itself. So self loops will be there. So we will draw the self loops. That is 5 divides 5, 6 is related to 6, 8 is related to 8, then 10, 28, 36 and 48. So these loops will be there. Now see, just consider 5. Now this 5 is related to, or 5 divides 10. So this edge will be there with the arrow. Then just go to 6. Now 6 divides which number? That is 6 divides 36 and 6 divides 48. So this edge will be there. Now then 8. Now 8 divides which number? That 8 divides 48. So this edge will be there. And then the rest 10, 28, 36, 48, they does not divide any number except themselves. Okay. So this will be the diagram. Now we will construct a haze diagram. Fine. So the first step, all the points will be same. Okay. So all the points will be as it is. So that means 5, 6, 8, 10, 28, 36 and 48. These points will be the same. Now for haze diagram, the first step is remove self loops, as the relation is already reflexive relation. So here in diagram you can see all this, how many self loops are there? There are 7 self loops. So in haze diagram the self loops will be removed. Okay, so no self loops will be there. Now second step. Now what was the second step? In second step the directions will be removed. So that means this arrows will be removed. Fine. Now then the third step. Now the remove transitive edges. Now see, just consider here there is no transitive edges. We will discuss in later examples. Fine. And the fourth step, we will draw edges in such a manner that it will look in upward direction. And just by looking at the edge, we will be able to say that this point is related to this. For example, see, you can see that this 5 is related to 10, and so we will draw like this without direction, and just by looking at this we will be able to say that this 5 is related to 10. So that means the relation, it is in upward direction. Fine. Now then 6 is related to 36, so we will draw like this, and 6 is related to 48. So in upward direction 6 is related to 36 and 6 is related to 48, and last 8 is related to 48. So that means this edge will be there. So this is the haze diagram. Okay, and here the 28 is alone because the self loop is removed. Now let us discuss another example. Now question, draw the haze diagram of the following set under the partial order relation, that is the divides relation. So the relation is same, the sets are different. So the first set is this A equals to 2, 4, 12, 24, and the second set, that is 1, 3, 5, 15 and 30. Now see, here A equals to 2, 4, 12, 24. So the relation will be what? So see, it is the divides relation. So first, see, each and every number divides itself. So 2, 2, 4, 4, 12, 12, 24, 24. These pairs will be there. Now just fix 2. Now 2 divides 4, 12, 24. So this all these three pairs will be there. That is 2, 4, 2, 12 and 2, 24. Then next 4 divides 12 and 24 as well. So 4, 12 and 4, 24 will be there. Then next 12, 12 and 12, 24, and last this 24, 20. Now see, in this example we won't draw a diagram, we will directly draw the haze diagram. So the first step, so the haze diagram will be, just take all these points, that is 2, 4, 12 and 24. Now we will see this 2, 2, 4, 4, 12, 12 and 24. We will directly draw the haze diagram. See, so which pairs will be there? So we will decide. See, 2, 2 pair will not be there. Why? Because it is a self loop. So that won't be there. Now 2, 4. Now 2, 4, is it a transitive relation first? So no, it is not a transitive relation. So first step, this 2, 4 pair will be there. Fine. Now 2, 12. Now it is a transitive relation. Is it a transitive relation or not? Yes, it is a transitive relation. How to decide? See, 2 and 12. This 2 and 12. Now in between 2 and 12, can we put some number such that it becomes a transitive relation? So how? See, you can see that this 2 is related to 4 and 4 is related to 12. So that means 2 is related to 12. So this is a transitive edge. So this 2 and 12 directly to 12 pair won't be there. Fine. Now in same manner 224. So 224, can we put some number in between such that this edge is removing, or such that it is a transitive edge? So 224. So we can put 4 or 12 because 2 is related to 4 and 4 is related to 24. So also this edge won't be there. Now 4, 4, that is a self loop. Now 4 and 12. Now 4 and 12, in between we cannot put any number. So this edge will be there. Fine. Now 4 and 24. So 4 and 24, in between we can put 12. So it is a transitive edge, so that won't be there. Now 12, 12, that is a self loop. So then 12, 24. Now 12, 24, in between we cannot put some number. So 12, 24 pair will be there. And 24, 24, that is a self loop. So that's it. So this is how you can construct a haze diagram without using that diagram. Fine. So this is the Hayes diagram. Next, the second example, 1, 3, 5, 15 and 30. So first we will write the relation. So the relation will be like this. How? See, the same steps. All the numbers divides itself because it is a divides relation. So 1, 1, 3, 3, 5, 5, 15, 15, 30, 30. These pairs will be there. Now 1 divides each and every number. So 1, 3, 1, 5, 1, 15, 1, 30. This S also will be there. Then this 3 divides 15 and 3 divides 30. So 3, 15, 3, 30. Then next 5 divides 15 and 30. So 5, 15, 5, 30. And 15 divides 30. So 15, 30. So this is how the relation will be. Okay. Now we will again construct the Hayes diagram directly. So let us take all these points. That is 1, then 3, then 5 and 15 and 30. So all will be in the upward directions because we are removing the arrows. So the first step, see, 1 pair won't be there because it is a self loop. Now 1 3. Now in between 1 3, can we put some number such that it becomes a transitive edge? So no. So that means just 1 3 will be there. Now it is in upward direction. So just by looking at it, we will be able to say that this 1 is related to 3. Okay, or 1 divides 3. Fine. Now in same manner, this 1 and 5. Now in between 1 and 5, can we put some number so that it becomes a transitive edge? No. So 1 5 pair will be there. Fine. Now then 115. Now 1 and 15. But in between we can put this 3. So that won't be there. Now in same manner 130. Now 130 we can put so many numbers. So this is a transitive edge. So it won't be there. Now just go to 3 3. Now 3 3. That is a self loop. So that won't be there. Now 315. Now 3 and 15. Yes, it will be there in the Hayes diagram. So 3 and 15, then 330, so it won't be there. Then 5 5, it won't be there. Then 515, 5 and 15, so in between we cannot put some number, so 515 will be there. Now 530, so 530 no, because it is a transitive edge. And last, this 1530 will be there because we cannot put some number. So this is how the Hayes diagram will be. Fine. And you can see that there is no self loop, there is no direction, but still using this Hayes diagram we will be able to write this whole relation. How? All the self loops will be there, that means all the 1 1 5 5 similar pairs, and then the transitive edges. Suppose we want to write this transitive edge, so that means 1 is related to 3, 3 is related to 15. So here 115 will also be there. So this is how you can write the relation from the Hayes diagram also. Thank you.